This is a simulation of the propagation of P and S seismic waves through the volume of the Earth. As the P waves propagate, they will continuously refract as they begin to move through the layers of the Earth itself. And the reason for that is because as the layer, for example, progresses, then physical properties of it begin to change: density, pressure, temperature, and so on. This ultimately changes the speed of the seismic wave. In addition to that, you're also going to see the S waves as well. The S waves, however, will not refract into this layer of the Earth right here. And the reason for that is because this right here is the outer core, which is liquid. Transverse waves, S waves, do not propagate through liquids. So this is one of the reasons why we know that the Earth's outer core is a liquid, because S waves do not propagate through it. Another reason that we know that it's a liquid is because it's the source of the Earth's magnetic field. Okay, and then roughly right up here, very thin, is the crust. Here's the mantle, here's the outer core, and then here's the inner core. Okay, as I set this film into motion, you're going to see the P waves as orange and red, and you're going to see the S waves as blue and green. They're also going to trace out a couple of lines here that are black. That will then show the direction of propagation. So we understand where the physical layers of the Earth are. We understand their physical properties through simulations such as this. That is the propagation of seismic waves through the Earth's interior. And then out here, for example, along the Earth's surface, this is then where we place seismometers to detect then the reception of those seismic waves. So let me go ahead and set this into motion here. Oops. Like so, there we go. Okay, so notice how the waves change speed and direction as they move through the individual layers themselves, and then ultimately also how they refract through the layers. And then over here, this is then where we would place various stations for the reception of those seismic waves with seismometers. Okay.